Good evening children, welcome to the chemistry class. And in the previous class we have started discussing about the chemical classification of matter, right. So under chemical classification of matter we have proceeded and we have categorized the matter on chemical basis into pure substances, mixture. Pure substances we have started discussing about it, and according to the concept of a chemist, generally sometimes we say some of the substances as a pure, generally we call them as pure, but they are not exactly pure as a chemistry point of view. For example, if you look at the tap water, of course as you collect the tap water in a glass it looks very clear and it looks very pure, but of course when you look at the inside of that particular component water, you can clearly see some of the dissolved salts in it along with the dissolved air in it. Okay. So, it is not a pure, it is a combination of the pure substances, let us say. Okay. Milk, as it looks very pure, honey looks very pure, but of course these are not pure. In case of milk it is a combination of fat, carbohydrates, minerals, vitamins, etc. Honey also along with the presence of the sugar, it also contains some other components in it. So, this is, as it looks very clear, very pure, but it is a combination of different components. So, we cannot say it as a pure substance. Okay. Similarly, in the case of fruit juices as well as the medicine that we are going to take, they are also not pure. Okay. Since the fruit juices contains mineral, vitamins along with other components. Medicines, one component is not used as a medicine perfectly, because in order to make it in the form of a tablet or in order to increase its solubility in the body, in order to increase its activity, somehow other components will be added to it, and thereby the medicine is a combination of different substances. It is not exactly the pure compound. Okay. Now, let us look at the further classification of pure substance. We know in the last class we have seen pure substances can be further classified into elements and compounds. Elements are further classified into metals, non-metals and metalloids. Okay. So, today let us focus on what are the elements and how we can categorize an element, how we can define an element. So, all these things we are going to see in this today's class. Okay. So, today's class we are going to look at the element and its classification, and the how we can categorize, how we can define the element, and how we can look into the element, and how many different types of elements are available to us. All these things can be discussed under this particular thing. Okay. So, just go through the definition, I will explain you. So, here if we observe the definition, element is defined as the basic form of matter. So, element, if you look at the element, as we categorize the matter into solid, liquid and gas based on the physical states. So, whatever may be the physical state of the matter, every matter is made up of element only, and of course element will be the basic form of the matter, but it cannot be further broken down into simpler substances by chemical reactions. So, by employing chemical reactions or by using the chemical reactions, it is not possible for us to divide the element further into simpler form. So, further simplification of a substance is not possible by chemical means. That substance can be taken as an element, and element is the basic form. So, here we can say that if we are going to take the matter, matter is made up of element. Okay. Matter is made up of element. So, we can consider the matter as the basic form of, or the basic form of matter is element, or we can consider element as a basic form of matter. So, here you can clearly see that matter is made up of element. So, automatically element becomes the basic form of matter. Matter, whether it is a solid, what we have discussed in the previous week, liquid or gas, whatever may be it is made up of one or two elements. So, basic form of matter is element, and it cannot be further divided into simpler substances by chemical reactions. So, element is the basic form. Otherwise, in one more definition we can clearly say that the substance which is capable of giving the same atoms on fine division, the substance which is capable of giving the same atoms on fine division is generally called as an element. How to define this one? So, this is second way of defining the element. Okay. So, we can take for example, if I take a hydrogen element, if you are going to take a hydrogen element, hydrogen in nature will exist as H2 gas and it is a combination of hydrogen atoms. So, whenever we look at the hydrogen element, whether you take the hydrogen element here in India or in United States of America or in any country or in any area, it is going to contain only one kind of atoms. What are they? Hydrogen atoms. Okay. So, hydrogen is made up of hydrogen atoms. So, hydrogen atoms are going to be come out when I am going to divide this hydrogen gas. So, hydrogen element on fine division, when we go for fine division, if I am going to cut the hydrogen element, I am going to end up with the formation of hydrogen atoms only. So, this is a substance which is giving same atoms, the substance which is giving same atoms on finer division. So, when we are going to divide it, in that case we are going to end up with the only one type of atom. So, that substance is taken as an element. Element is generally going to give us only one kind of atoms on fine division, or the substance which is going to give us the same atoms on fine division can be taken as an element, or we can define it as the other way around. It is the basic form of matter which cannot be further divided into simpler substance. Okay. So, it is the last. For example, if you take a oxygen element, in case of oxygen element, when we go for fine division, if you are dividing the oxygen element into fine division by chemical means, okay, by chemical means, we end up with the only one type of atoms. What are they? Oxygen atoms. So, oxygen is a substance on fine division giving only oxygen atoms, okay, which is giving only same atoms, is generally called as an element. Okay. Substance which on fine division gives only one type of atoms, that is taken as element, or we can define it with respect to the matter as it is the basic form of the matter. Element is the basic form of the matter that cannot be broken down into simpler substances, just by chemical means. Of course, we can break it down into simpler substances maybe by physical means, but through chemical reactions, by chemical means, by using the chemical concept, we cannot divide element further into simpler substances. So, that is taken as an element. Okay. Right. For example, you can take hydrogen, nitrogen, oxygen. Similarly, you can write here also nitrogen in nature exists as N2. So, we can take nitrogen as an element. Nitrogen, when we are going for further division, what we can get? We get only nitrogen atoms, not other atoms. Similarly, carbon on fine division will give only carbon atoms. So, automatically carbon is an element. Okay. Similarly, if we are going for aluminium, aluminium on further division will give only aluminium atoms, no other atoms. Similarly, sodium on further division, fine division will give only sodium atoms, no other atoms. So, sodium is an element. Okay. Calcium, similar way, it on fine division will give only calcium atoms, no other atoms. So, automatically calcium can be considered as the element. Okay. So, how many elements we can expect in the nature? How many elements are there today with us? So, if you observe this table, I think by looking at this table you can easily identify it is the long form of the periodic table. So, what is it? It is the periodic table. What do you mean by periodic table? Periodic table is a table in which all the elements are arranged. Of course, the elements which are having similar properties are arranged in a one particular group. Okay. And if you observe this particular periodic table, if you observe the total periodic table, you can clearly observe 1, 2, 3, 4, 5, 6, 7. 7 periods are present, and in this case if you take around 18 groups are going to be seen. So, 7 periods and 18 groups are seen in the periodic table. And if you observe the total elements present in the periodic table, you can clearly observe that we have around 118 elements. How many elements we have? We have 118 elements today. Okay, today we have 118 elements. Of course, 119th element and 120th element, the research on these two elements is going on in Japan. Maybe by 2021 we may expect those two elements to also occupy the periodic table. Okay, right. At present we have 118 elements with us, and all these elements are arranged in the periodic table. You can clearly see here alkali metals, the yellow colored ones are alkali metals. Here you can observe lithium, sodium, potassium, rubidium, cesium, francium. These are all alkali metals. Next one is alkaline earth metals, these ones. Okay. Basic metals you can observe here: aluminum, gallium, indium, tin, lead, thallium, etc. Halogens, you can see the halogen, fluoro, chloro, bromo, iodo, astatine, etc. Okay. Noble gases, look at the last extreme column here, you can observe helium, neon, argon, krypton, xenon, radon, they are all noble gases. Okay. And non-metals, if you observe this portion, carbon, nitrogen, oxygen, sulfur, phosphorus, selenium, they can be considered as non-metals. Of course, these are also considered, halogens also considered as non-metals. Semi-metals, this is green colored one is semi-metal, you can see here semi-metals, germanium, arsenic, antimony, tellurium, polonium, they are semi-metals. What do you mean by semi-metal? Semi-metal means it is going to exhibit the properties of metal as well as the properties of non-metals, both are present in that case. Transition metals, you can observe the light blue colored ones which are present in the middle of this particular periodic table. If you observe, they are the transition metals. So, transition metals are occupying the middle portion of the periodic table. Okay. And the non-metals are occupying this area, and this side also we have alkali metals, alkaline earth metals. So, this total portion is occupied by metals. Okay. And if you observe the portions in this case, this side is the left side portion of the periodic table and this is the right side portion of the periodic table. The noble gases are present at the extreme right side of the periodic table. Alkali metals are present at the extreme left side of the periodic table. Transition metals are present in between the or you can say it is they are present in the middle of the periodic table. Okay, right. And if you observe here, one of the element is shown in a little bigger in size. So, the symbol can be written in here and its name is written here. Okay. So, we represent the element symbol and the chemical name is given for the particular element. And here if you observe the top side, right side top position, atomic mass is given, the mass of the atom is given, and here we have the atomic number. So, all the elements that are given in this particular periodic table all are written in the same fashion: symbol, the name of the element below it, the right side we have atomic mass, left side we have the atomic number. So, the similar way all the elements, their symbols, their masses, their atomic number and their names are given in the periodic table. This is common in any periodic table. If you have in your textbooks, just go through the table that is given in your textbook. There also they are going to mention the same thing. Okay, right. So, in total, how many elements we have in our periodic table? We have 118 elements. So, all these elements on fine, these are the substances which are on fine division giving only same atoms, one kind of atoms. Therefore, all these are said to be elements. All these are said to be elements, right. The elements may be solids, okay. The elements may be liquids or the elements may be gaseous elements. They can be solid or they can be liquid or they can be gases. As we have defined the element in the beginning as a basic form of the matter, basic form of matter. So, basic form of matter, so matter can be solid, matter can be liquid, matter can be gas. So, automatically element can be solid or elements may also liquids, elements may also the gaseous substances. Let us look first the gaseous elements. how many gaseous elements we have in our periodic table. So, among all the elements that are known to us, that is to say that around 118 elements that are known to us, only the 11 elements that we are going to discuss now are gases. What are they? Hydrogen, nitrogen, oxygen, fluorine, chlorine, and all noble gases, all the noble elements, they are also gases. So, how they are existing in nature? We have already seen hydrogen exists in nature as H2, nitrogen exists as N2, oxygen will exist as O2, fluorine will exist as F2, chlorine will exist as Cl2. So, if you observe these elements, they are all, for example, in the case of hydrogen, hydrogen is existing as H2. How many atoms are there? We have 2 atoms. So, it is a diatomic molecule. Similarly, nitrogen in nature exists as N2. So, N2 is also a diatomic molecule because it contains 2 nitrogen atoms. Oxygen exists as O2. 2 oxygen atoms are present. So, it is also diatomic molecule. Similarly, fluoro and chloro also diatomic molecules. So, these are diatomic gases. What are they? Oxygen, nitrogen, hydrogen, fluorine, chlorine, all are diatomic gases. How many we have? 1, 2, 3, 4, 5. So, total 5 diatomic gases we have. Okay. And if you observe the noble gases, helium, neon, argon, krypton, xenon, radon. Helium, neon, argon, krypton, xenon, radon. In nature, these elements, noble elements, existing as monoatomic gases. How they are existing in nature? They are existing as monoatomic. What do you mean by monoatomic? They exist in nature in a single atomic form only. Helium in nature exists as He only, not as He2. Okay. Here if you observe, hydrogen is existing as H2, but helium, neon, they will exist as He, Ne only. Argon will exist in nature as Ar. Krypton exists in nature as Kr only. Xenon in nature exists as Xe only. Okay. So, these are therefore called as monoatomic. They exist in nature in a only one atom, as a one atom. So, they are called as monoatomic. These elements exist in nature with the 2 atoms. So, they are called as diatomic. If any element existing in nature in a 3 with the 3 atoms, it is called as triatomic. If it is 4 atoms are present, we call it as tetraatomic. If 8 atoms are present, we call it as octaatomic. Okay. So, the number of atoms that are present will give using that we are writing the diatomic and monoatomic. How many monoatomic gases we have? We have 1, 2, 3, 4, 5, 6. Total 6 monoatomic gases we have. So, we have 6 monoatomic gases and 5 diatomic gases. So, 5 plus 6, how much? 11, yes. So, 11 elements in the periodic table, okay. 11 elements in the periodic table are gases. How many elements in the periodic table are gases? Only 11 elements in the periodic table are gases. How many elements we have in the periodic table? 118 elements. So, among the 118 elements, only 11 elements are gases. Okay. Let us look at the liquids. How many elements will exist in liquid form? Among all the elements that are known to us, that is among the 118 elements that are known to us, only mercury, Hg represented with Hg, okay, bromine represented with a Br are liquids at room temperature. Only these 2 are liquids at room temperature, at room conditions, under room conditions. Mercury exists as liquid, and similarly bromine also exists as liquid. And if we observe, mercury is metal. What is mercury? Mercury is a metal. What are metals? We will come across again, we will discuss that one also, metals etc., non-metals, metalloids, we are going to discuss all those things. Okay. So, only liquid metal, the metal which exists as liquid state at room condition is mercury. What about other metals? All metals generally they exist in solid form under room conditions. Under room conditions, all the metals will exist as solids, but only metal which exists as liquid is mercury. Mercury we represented with Hg. Mercury we represent with a Hg symbol, capital H and small g, okay. And when you observe the bromine, bromine is a non-metal, and most of the non-metals are gases, okay. Most of the non-metals are gases, but only non-metal which exists in liquid form is bromine. Only non-metal which exists in liquid form is bromine. Only metal which exists as liquid is mercury. Only non-metal which exists as liquid is bromine, okay. So only two elements they are existing as liquids at room conditions, okay. What about the solids then? Solids other than the elements which are other than the gases and the liquids, they can be considered as solids. So we have total how many elements ma? We have 118 elements. So among them we have discussed 11 elements are gases, okay, and just now we have seen 2 elements are liquids. So remaining ones, what are remaining ones? 13, remove 13 from 118, so 105 elements that are existing, that are present are solids. Around 105 elements they are existing as solids, okay. You can see here all other elements except gaseous and liquid elements are solid elements. So around 105 elements are existing as solids. So a common example that we can see, carbon in nature exists as solid, diamond form and graphite form. Sodium, metals, sodium, potassium, calcium, barium, so all these elements are existing in nature as solids, okay, right. Now let us look at the further classification of elements into, just now we have seen the elements classification as gaseous elements, liquid elements and solid elements. Now let us focus on the classification of elements as metals, non-metals and metalloids. Metals, non-metals and metalloids. So elements further divided into 3 categories: metals, non-metals, metalloids, okay. Now let us discuss about the elements which can be seen as metals in the periodic table. So what are metals? Where we can find the metals? So if you observe the periodic table, among the elements in the periodic table, how many metals are present? More than 75% are metals. More than 75% are metals. So among the total elements that we have seen, 118 elements in the periodic table. So among the 118 elements, more than 75% of elements are only metals. So metals are occupying more portion in the periodic table, okay, that you have to see. And where we are going to find these metals in the periodic table? Generally these appear on the left side of the periodic table. Just now as I have shown you the periodic table, the long form of the periodic table, I told you that the left side, extreme left side we have metals, the right side we have the non-metals, okay. So where we can find the metals in the periodic table? They appear on the left side of the periodic table. So left side of the periodic table you can find these metals, and generally metals are solids at room temperature. So under room conditions of temperature and pressure, generally the metals are solids. Since they are solid in nature, you can see the picture: aluminium, iron, copper, of course the steel, bronze, brass are the combination of metals that we can come across, okay. So here if you observe, because of the solid nature they are having under room conditions, what they are going to possess? They are going to possess very high melting and boiling points. They are going to possess melting points and they are going to possess boiling points as well. But of course what are the values? The values are very high. So metals generally can possess, or they exhibit high melting points and boiling points. So metals exhibit high melting points and high boiling points, okay. And one more thing you can observe, metals are good conductors of heat and electricity. They are good conductors of heat and electricity. Have you got a chance to see what is present in the case of a wire, electrical wire? Generally in order to run the fan, or in order to switch on the tube lights or the lights or the TV, etc., what do? We connect through a wire, right? Have you seen when the wire is cut into 2 pieces, have you observed anything present inside? Yes. So, you can also observe in the case of a cable connection, the TV is connected with the cable, right, the DTH or the maybe the cable operator has giving you wire. So, in that case if you observe, it also contains some solid component. What is that? They are metals. Okay. So, the wires that you observe, the inside material if you observe, they are all metals, because metals are good conductors of heat and electricity. So, electrons are present in the metal and they are capable of conducting the electric current as well as the heat. So, they are considered as good conductors of heat and electricity, and these are malleable as well as ductile. So, we can make the metals to form a very long sheets, or we can convert them into a small thin wires. So, converting them into the sheets, we can convert metals into sheets as well as metals into wires. So, that is called as malleable and ductile. The metals will react with the acids. When the metals react with the acids, hydrogen gas is going to be generally released most of the times. Okay. Most of the times hydrogen gas is going to be released in most of the cases when the metals are going to react with the acids. Okay. So, we can say that the metals are going to possess high melting points and boiling points, and when you observe the periodic table, so the left portion of the periodic table, the left side portion of the periodic table is generally occupied by metals, and how many metals we have? More than 75% of the elements are metals only. So, around 118 elements we have. So, among these 118 elements, more than 75% are metals. Okay. And they are good conductors of heat and electricity. You can clearly see, for example, when the heat conduction, if you observe, if you are keeping a iron rod in a hot summer sunny day, in that case, if you keep half portion of the metal rod into exposure to the sun and half portion in a shadow, so automatically as soon as the rod that is exposed to the sun got heated up, in that case what happens? The heat will flow through the rod, and you can feel the heat the other side as well. Okay. So, when you are keeping a metal rod in a sunny hot day, in a summer day, half portion if you expose to the sun and half portion if you are keeping in a shadow, automatically the heat that is taken at one end gets transferred to the other end. You can feel that heat at the other end as well. So, this clearly indicates that the metals are, iron is a metal, right. So, iron is a good conductor of heat and electricity. Okay. And these are converted into very long sheets by hammering with a hammer. So, automatically what we can make them into a long sheets, and we can make them into very thin wires. So, we can convert them into sheets and we can convert them into wires. So, that can be happen with the metals. They are going to react with acids. So, metals are going to react with acids, and during that process they will release the hydrogen gas. It is generally the common reaction that we encounter in case of metals. Okay. So, I think today we have covered about the elements definition as well as the metals components discussion. We will come up with some more interesting topic with respect to the non-metals and as well as metalloids in the next class. Until then, have a nice time. Thank you.